So the first thing that we're going to look at is the difference of two squares, which is basically the same thing we've already looked at, but in reverse. We've already looked at how we could multiply a sum and a difference. Whenever I have a plus b, a minus b, that always multiplied to give us a squared minus b squared. Well, so if we notice that I am subtracting two perfect squares, then the reverse of that is also true. So if we look at number 10, this is x squared minus 2 squared. So x is a and 2 is b. I can very quickly factor this to be x plus 2 and x minus 2. It will always work out that way where we have one sum and one difference. So look ahead at number 11. So look at what the two things are and see if you can figure out what we're squaring for each one. So here I have 6x squared minus 5 squared. So think of what our factors would be. We would have 6x plus 5 and 6x minus 5. And that's done. Looking at number 12, it looks like it might be a little bit different, but it's really not, because any power that is even is a perfect square. And the reason why is because if you remember when we do the power of a power, we multiply. So whenever I have an exponent and I square it, what I'm really doing is I'm doubling that. 2 times 2 is what gives me 4. Similarly, like x to the 5th squared would give me x to the 10th. I just double this exponent. So if I can divide it by 2, that means I can write it as a perfect square. So this is x minus 2 squared minus 9 squared. And so when I write this out, a plus b, a minus b, I get x squared plus 9 times x squared minus 9. Now this one's interesting for a couple of reasons. If we look at this again, you might notice that we end up with a second difference of two squares. X squared is a perfect square, and 9 is a perfect square. So that means that we can factor this even further to x squared plus 9 times x plus 3, x minus 3. And that is going to be the correct answer because now we have factored it as far as we can possibly go. Now, something else that I want to add here, which is not in these notes, so you might want to jot this down off to the side, is that I want to take a second to talk about perfect square trinomials. These are important to see as well. You can get to these without knowing that it's a shortcut, but it is a good thing to notice. So think back to when we multiplied and we said when we square a binomial, like x plus 5 squared, that was our little sort of chant. We square the first, we square the last, we multiply, and then we double. We always take this sign right here. So I get x squared plus 10x plus 25. So whenever we look at a trinomial, if we notice that the first term is a perfect square and the last term is a perfect square, as long as we check to see, this is x to the second, this is 5 to the second, can I multiply and double to get to this middle term? If that is, then we know that that's going to be one where we get a repeated factor, something to the second power, for example. So let me show you a couple where this would work. So here's some examples of perfect squares. Let's say that I had 9x to the second minus 6x plus 1. Now again, I look at these two things. 9x squared, that's going to be 3x to the second. And 1 is a perfect everything. This would just be 1 squared. So now what I want to look at is if I multiply these, I get 3x. And if I double that, do I get 6x? And the answer is yes. So that tells me that this is going to factor to have a 3x and a 1 squared. And then remember, this is the sign that it always comes from. So this would be our factors. You have to make sure that you check that middle term. Here's an example of one that is not a perfect square. Okay, let's say that I had 4x squared plus 10x plus 9. Well, this is 2x to the second, and this is 3 to the second. So it's promising so far. I have two perfect squares. But when I do 2 times 3, I get 6. And when I double that, I get 12. That doesn't match what's here. That doesn't mean that that's not factorable. It just means that it's not a perfect square. Okay? So, again, here would be one more example of one that is a perfect square. Let's say that I had 4x squared minus 12x plus 9. Now the middle term gives us what we want, and this would come out to 2x minus 3 squared. So that's another little shortcut that you can use. Now, we have the difference of squares. Notice there is no sum of squares, but when we get to cubes, we do have a sum and a difference of 2 cube formula. So again, it's really important that we recognize those perfect cubes, okay? So if I have a cubed plus b cubed, it always factors to a plus b, a squared minus ab plus b squared. Now again, I'm not going to give these formulas to you, but not hard to come up with. So you see that the coefficient is 1 on every single one of these. It's 1a, 1b, 1a squared, 1ab, 1b squared. So that is easy to remember. But here's the part that's hard is where you put the signs. And you see they tell you same signs, opposite signs, always positive. Same signs, opposite signs, always positive. You can remember SOAP. SOAP will help you remember which way to put the signs. Same sign, opposite signs, always positive. And when we do the difference of 2 cubes, it's the same. It's a, b, a squared, ab, b squared. But we have same sign, opposite sign, always positive. So let's look at a couple of examples here. I'm going to move this down to where we don't see the formulas anymore. So the first one is an example of a sum of cubes. So I have x to the third power plus 1 to the third power. So a is x, b is 1 in this case. So it goes like this, x and 1, and then I'm going to have x squared. 1 times x is just x, and you don't double this one, you just multiply them. And then 1 squared is 1. Same sign, opposite signs, always positive. Done. Those are our factors. So again, look at where this came from. This is a plus b, a squared. It's squared, not cubed, because when I multiply the first a times this a, that's where I get the cubed from. Then this is a times b, and this is b squared. Same sign, opposite sign, always positive. Let's look at number 14. 125x to the third minus 8. First, I notice I have 2 terms, and this has a cubed on it, so that is sort of my clue that I should probably check, to see if negative 8, or if 8 and 125 are perfect squares, or cubes, rather. And they both are. This is 5x to the third, and this is 2 to the third. So think about how we would set this up. The first factor is going to be 5x minus 2. It's exactly the a and the b that we had, and we keep the same sign. Then we square it, 25x squared. We multiply them, 10x, and we square the last one, which gives us 4. And now if I go back and look at my signs, I have same sign, minus, opposite sign, so this one is a plus, and then always positive, so this one is a plus. You'll just have to practice so that you can remember those formulas.